Okay, let's dive deep. We've got this incredible stack of source material here today, all about a really fascinating theoretical framework. It's called the electrogravimagnetics construct, or just EGM for short.
Right.
Think of this as your shortcut, really, to understanding a potentially radical new way of looking at physics.
Yeah, that's a good way to put it. Our mission, based on these sources anyway, is to unpack
Mm-hmm.
this pretty complex theory. We want to get the core ideas right, see how it, pushes back against established physics, like the Standard Model of Cosmology, SMOC they call it, and explore some of its really surprising predictions. Stuff about particles, gravity, the universe itself.
Because it makes some really bold claims, doesn't it? Right from the start. Things that go against ideas we've, well, held for a long time.
Oh, absolutely. Things that definitely make you stop and think.
Yeah.
Like the idea that photons might not actually be massless,
Well, right.
or that dark energy isn't what SMOC says it is at all. It really forces you to kind of reevaluate some fundamental physics concepts.
So let's start at the beginning then. Where does EGM build its foundation? What's the big idea?
Well, EGM sets out with this incredibly ambitious goal, right? To create one single unified picture for all the fundamental forces.
The dream, basically.
Exactly. And describe the universe across all scales. I mean, from the tiny quantum level way up to the biggest cosmic structures.
Wow. Okay, unifying everything. What's
Yeah.
the single principle they say makes it all work?
The sources keep pointing to this one core concept, something called the Fourier spectrum quantization of gravitational acceleration, or just G.
Quanta is G.
Yeah.
Right.
And EGM posits this isn't just an idea, it's the fundamental source from which literally every single result in their framework comes. Whether it's particle sizes or how the cosmos evolves, it's the engine.
Okay, so gravity isn't just like ESMA or curving spacetime.
Hmm.
It has this deeper frequency-based structure. How does that manage to link quantum mechanics and relativity? They seem so different.
Well, it integrates them using specific parameters that supposedly arise from this G quantization.
Hmm.
So quantum mechanics get pulled in via something they call NPV,
Hmm.
which is like a harmonic multiple derived from G.
Okay.
Newtonian mechanics is there through the familiar GMR2 gravity term. And then general relativity is incorporated using KPV. They call that the refractive index of spacetime.
Refractive index of spacetime.
Huh. It's their way of trying to weave these, traditionally separate fields together.
And speaking of things that sound different, EGM apparently has some core beliefs about the universe that feel pretty counterintuitive compared to standard physics,
They
right?
certainly do. The sources highlight three big ones. First, and maybe the most startling, is the claim that photons are not massless.
Wait, photons have mass, but isn't the whole point in the standard model that they're pure energy, zero rest mass, travel at sea?
Exactly. That's the massive pointed apart, pardon the pun. EGM just fundamentally disagrees with that core assumption.
Okay.
Their second tenet is about gravitons, the hypothetical gravity particle.
Mm-hmm.
EGM defines a graviton as an entangled pair of, get this, conjugate wave function photons.
So gravity particles are made of light particles.
In their model, yes, entangled pairs. And the third big idea is that all matter exists in this energetic equilibrium with the space-time manifold around it, like particles are constantly balanced with the fabric of space-time.
Wow. Okay, those three, photons have mass, gravitons are photon pairs, matter in equilibrium. That's the bedrock.
That's what the sources present as the bedrock, yeah.
So how does this whole EGM thing connect with other, maybe less mainstream models out there? Like I've heard of the polarizable vacuum model or zero-point field theory.
Good question. The sources describe EGM as sort of an interface. So the polarizable vacuum or PV model
Yeah.
that's presented as this alternative way to think about gravity, more like how light behaves in a medium. Sometimes it's mathematically equivalent to GR, actually. EGM then acts as a kind of quantized mathematical bridge between that PV model and zero-point field theory, or ZPF. And ZPF is that branch of quantum field theory dealing with the vacuum energy, the energy of supposedly empty space.
So it's like layers.
Kind of, yeah. They even visualize it as a solution pyramid. You've got GR at the base, the PV model in the middle layer, and then the more quantum ZPF theory at the top. EGM sits right in that middle layer, connecting the sort of classical view of GR and PV up to the quantum ZPF.
And if this whole EGM structure actually holds up, what's the ultimate payoff?
Oh, the potential payoff is enormous. If EGM gets validated, it claims to finally solve that huge, long-standing problem in physics, reconciling quantum mechanics and general relativity.
That holy grail.
Pretty much. Getting one consistent description for everything. That's what physicists have been chasing for, what, a century.
Okay, that sets the stage really well. We've got the big picture, the foundations. Now let's use this EGM lens, like you said, and zoom right in on the smallest things we know, elementary particles.
Yeah.
How does EGM describe them?
Right, so EGM comes at particle physics using these harmonic representations. It's almost like particles are specific frequencies or resonances within that whole GE quantization structure we talked about.
Like musical notes.
Sort of, yeah. It's interesting, though, they do note that the neutron is a bit of an outlier, an exception to this general harmonic rule in their system.
And they actually calculate sizes for these particles, right? And compare them to the standard values we measure.
Exactly.
So how do EGM's numbers stack up? Are they totally different?
Well, EGM's derived harmonic radii are remarkably close, actually. And they also have this conjecture that quarks are incredibly tiny, like maybe 0.5 AM. They really stress that their specific method for getting these hadronic measurements has gotten some empirical backing from experiments like SELEX, and also from independent work by researchers like Kopecky and Rees.
One thing the source material really seems to hammer home is the internal consistency within EGM's particle calculations.
Yes, absolutely. They present this as a major strength. EGM apparently shows an internal consistency of something like 99.99% across the different ways they calculate these radii, whether it's based on mass or Compton wavelength, or their specific harmonic unification approach.
That's pretty high consistency.
It is. And they cite that high level of agreement as, strong evidence that the framework is internally sound.
And that refractive index of space-time, KPV, that pops up here again, too.
It absolutely does. EGM puts forward what they call a refractive index form for particles, which explicitly shows how QM, Newtonian mechanics, and GR principles are all woven together, and it's mediated by this KPV.
So it's like the glue holding it together.
Kind of, yeah. The fact that KPV shows up consistently everywhere, describing the vacuum, influencing particle characteristics, it really points to EGM's view of the vacuum, not as just empty space, right?
Right.
But as an active structured medium. And its properties, summed up by KPV, fundamentally shape how particles behave and interact.
Okay, let's circle back to that really radical claim. Massive photons. How does EGM actually put a number on that? Because that's such a departure.
It really is a core point where they diverge from the standard view. EGM explicitly states photons are massive. Now, it's worth mentioning, right, that while the standard model assumes zero mass, the official particle data group, the PDG, they actually leave the door open for a potential tiny photon mass. It just hasn't been measured.
Right, there's an experimental upper limit, but it's tiny.
Exactly. But EGM provides specific derived quantitative values for this mass.
Okay, so what kind of mass are we talking? Is it measurable?
Extremely small. According to the source material, EGM calculates the photon mass energy at about 3.195 times 10 to the minus 45 electron volts.
Minus 45, wow.
Tiny. And the graviton mass energy, feeding their entangled photon pair idea, is exactly double that, around 6.390 times 10 to the minus 45 eV.
Okay.
And these incredibly tiny values, along with predicted tiny diameters, were apparently predicted within the EGM framework by Sturdy way back in 2005.
2005. Before a lot of the precision cosmology data we have now.
Years before, yeah.
Yeah.
And here's a kicker. They note that even this almost impossibly small photon mass has a noticeable, significant impact on their calculated value for the Hubble constant.
That's wild, something that small affecting the whole expansion rate of the universe. Any other cool particle details from EGM?
Well, there's this specific analysis they do of the neutron's internal structure. Apparently, the EGM framework reveals this interesting connection between the proton's radius and a subtle feature inside the neutron specifically. It coincides with a turning point in the third derivative of the neutron's charge density distribution.
The third derivative. That's deep in the weeds.
It suggests some really deep interconnected structure within nucleons,
Okay.
And they even apply this whole framework down to something like the Casimir effect.
The force between plates in a vacuum.
Yeah. They use it as an example to show EGM can reach down to the nanoscale. They show how their model can calculate Casimir pressure, and even how it would change in different environments, like on Mars or in orbit relative to Earth. So demonstrating its reach, basically.
All right, so we've gone deep on the very small with EGM. Now let's pull way back and look at the really big picture, the cosmos itself. How does EGM describe the universe on its grandest scale? And how does that picture differ from the standard model of cosmology, SMO?
Okay, yeah, cosmology. A huge difference right away is how EGM deals with what Esmonsi calls dark energy.
The mysterious stuff making the universe expand faster.
That's the one. The EGM sources state very clearly that the effects we attribute to dark energy are organically derived from EGM's basic principles. It's not some extra mysterious ingredient they had to add later to make the observations fit.
So no separate dark energy concept.
Not as a distinct thing, no.
Okay, so where do the dark energy effects come from then?
They arise from the zero-point field, the ZPF. EGM proposes that the ZPF provides the actual cosmological expansive force. It acts as the necessary counterforce to gravity on cosmic scales. It's basically like applying Newton's third law action-reaction to the entire universe.
So the vacuum energy itself is pushing the universe apart?
That's the idea in EGM.
What about the cosmological constant lambda that's so central to Ismailmak's dark energy explanation?
Right. It's a function that changes over time.
A time-dependent cosmological constant. How does that change the story of the universe?
It significantly changes the interpretation of cosmic history. EGM actually passes through zero at a certain point, around 7.3 billion years after the Big Bang. EGM claims that SMSE misinterprets this as the moment accelerated expansion began.
But EGM says it's not.
Right. EGM's calculations show EGM then reached a maximum value more recently, around 10.9 billion years, and they claim SMC often mistakes that maximum value for the constant present-day value. EGM gives a specific lower value at the present epoch, around 7.9 by 1053 per square meter.
Now, one of the most, eye-catching parts of the source material is this claim EGM makes about predicting the Hubble constant, H0.
Yes, this is definitely presented as a major success story for the framework. Apparently, Storti, using just the EGM construct, predicted the value of H0 would be 67.0843 kilometers per second per megaparsec. And he did this back in 2008.
2008. And why is that date so significant?
Because it was years before the key satellite data, especially from the Planck satellite, came in. And that Planck data, released around 2013, confirmed a value remarkably close to Storti's prediction the PDG Planck value was 67.3.
Wow. So EGM allegedly predicted it from theory before the confirming observations, without needing the satellite data.
That's the claim, derived purely from their theoretical principles, predicting a fundamental constant like that years in advance. Yeah, that's powerful validation for any model, if true.
And have they refined that prediction since?
They have, using cosmic microwave background radiation CMBR data as constraints within their framework. EGM now derives a present epoch Hubble constant, they call it, of 67.118 kilometers MPC. And they give a very tight error margin, 0.0269.
Very precise.
Yeah, they highlight this as showing, 1, unprecedented resolution, and 2, excellent agreement or synergy with the latest official PDG 2022 value, which is 67.4.
What about the age of the universe? Does EGM calculate that with similar precision?
It seems so. EGM calculates the cosmological age, they call it the Hubble age, to be 14.5685 billion years. And again, with a remarkably small uncertainty, plus or minus just 5.8 million years.
14.57 billion years. That's older than the standard SMSE age, isn't it?
It is. SMOSE's age is around 13.8 billion years. EGM points out that their older age actually shows better synergy with the estimated age of the oldest known star, HD 142802803, which is around 14.46 billion years old, though with a large uncertainty.
Ah, the Methuselah star.
Right. So EGM suggests their framework might help resolve that potential tension, that crisis in cosmology, where the universe might seem younger than its oldest stars. They also claim their age aligns better with observed CMBR temperatures than the SMOSE age does.
Interesting. The sources also dig into the vacuum energy spectrum, something about Lorentz forces structuring the vacuum. What's the takeaway there?
Yeah, there's a detailed derivation mentioned. The gist is that EGM finds that the presence of electric charge actually imparts structure to their polarized vacuum model. In this structured vacuum, particles emerge as resonances, like specific harmonic modes within the ZPF spectrum. And crucially, they find that the energy density of this structured ZPF is finite. It avoids the infinity problems that can pop up in other QFT calculations of vacuum energy. They conclude that a theoretical bare vacuum, totally empty and unstructured, is simply undefined in their framework.
So the vacuum isn't empty. It's this dynamic, structured sea, and particles are like waves on it.
That's the picture EGM paints.
Yeah.
And it feeds into their whole view of deep interconnectedness. They emphasize this consistent mathematical thread linking the fundamental constants of nature, C, GH, the electron charge and mass, directly to the big cosmological parameters like the Hubble constant cosmic density, age, radius.
And that KPV thing is the link.
Exactly. Mediated by KPV, that space-time refractive index. It suggests potentially a deterministic universe where the physics of the very small is inherently tied to the physics of the very large.
Okay, so EGM has laid out its foundations, its view of particles, its cosmology. Now, how does this framework claim to actually solve some of the biggest outstanding puzzles that the standard model of cosmology is currently grappling with?
Right, this is where the rubber meets the road, so to speak. Let's tackle the Hubble tension first, that big disagreement between the Hubble constant measured locally versus from the early universe.
Yeah, that's a huge headache for cosmologists right now. Two really precise measurements, but they just don't line up.
EGM's position on this is, well, pretty bold. They state the Hubble tension does not exist within their
This
framework.
doesn't exist. How?
They argue the tension only appears to exist because the Hubble constant isn't truly constant across all space and time, the way esmophoria often treats it. In EGM, the value you measure inherently varies, spatially and temporally. Depending on the local mass distribution, the gravity wills around where you're making the measurement.
So the CMBR measurement reflects the average early universe condition, and local measurements reflect, well, local conditions, and they should be different.
That's precisely EGM's argument. They claim they use a single equation that can derive values consistent with both sets of measurements, depending on the input conditions. They suggest that if you could average local measurements over a huge representative population of galaxies, the apparent tension would simply vanish. They even point to specific galaxies, like M82, as places where measurements might test this idea.
Okay. What about the whole dark matter, dark energy issue? SMC basically had to invent these things to explain observations like galaxy rotation and accelerated expansion.
EGM offers a pretty sharp critique here. They argue that general relativity itself is incomplete precisely because it didn't naturally predict accelerated expansion or the effects attributed to dark matter and dark energy. EGM proposes what they call a more rational explanation for cosmic acceleration compared to Samoa's miraculous interpretation.
And how does that work in EGM?
It ties back to their dynamic cosmological constant, around 7.3 billion years ago. EGM says the actual transition to accelerated expansion, where Q becomes negative, happens later, around 9.63 billion years ago. They claim the standard model community, PDG, mistakenly identifies the earlier 0 point as the start of acceleration. They also argue their later Q0 timing validates an earlier prediction by Freeman and colleagues, seeing that as more support for their model.
Okay. And what about the flatness problem? The fact that the universe looks incredibly geometrically flat, which seems like a huge coincidence requiring fine-tuning in SMOF.
EGM tackles this head-on. Their fundamental starting point is just, the cosmos is flat. They argue it's maintained flat through some kind of oscillatory creation process. They state directly that the flatness problem is an artifact of SMLC making an unfounded assumption that cosmological curvature is constant.
Ah, so just like lambda and h, curvature also changes over time in EGM.
Exactly. EGM shows that cosmological metrics, including curvature, are not constant. They evolve.
How does it evolve?
According to their model, the universe was barely open right near the Big Bang. Then it briefly became maximally closed, and now in the present epoch, it's apparently flat. And in the far future, it'll become asymptotically open.
So the flatness problem just dissolves if curvature isn't constant.
That's the EGM argument, yeah.
Then there's that other huge puzzle. The massive difference in strength between electromagnetism and gravity, the many orders of magnitude problem. How does EGM handle that gigantic ratio?
Right, that mind-boggling ratio, something like 4.16 times 10 to the 42 for electrons. It's enormous. EGM's proposed solution connects this difference in force strengths directly to cosmological expansion.
Expansion affects force strengths. How?
EGM proposes something really radical, that the electron's fundamental charge, Q, was actually 0 at the very instant of the Big Bang.
Zero charge.
0 charge, while its mass was already its present value. Then, as the universe expanded, the charge evolved from 0 up to the value we measure today. This makes the ratio of the electric force to the gravitational force inherently time-dependent.
So the ratio wasn't always 10/42.
No, it grew from basically 0. The change is incredibly slow now, like 5 parts per billion per year, they estimate. But this evolution explains that vast initial difference. They also mentioned a related idea about a 90-degree phase difference in the quantum vacuum spectra between the electric and gravitational forces, which helps magnify the observed ratio while keeping the forces distinct.
Okay, let's swing back to dark energy again. EGM seems to challenge the very basic idea that the present moment, our now, corresponds to a redshift of 0, right?
That's correct. EGM calls SMOC's assumption of ZO for the present epoch a fundamental flaw.
So what does EGM use instead?
Their framework, drawing from that polarizable vacuum model, uses the relation 1 plus z equals 1 kPV, where kPV is that refractive index. From this, EGM derives a specific dark energy refractive index, K's which at the present time is actually greater than 1.
And if lambda is greater than 1?
Then the formula gives you a negative dark energy redshift.
A negative redshift. What on earth does a negative redshift signify in this context?
In the EGM framework, a negative redshift is the direct mathematical signature of accelerated cosmological expansion.
Ah.
They propose that the dark energy field is fundamentally a massive photonic field, and its effect is what causes this accelerated expansion, acting, as they put it, to stretch time. They also show that this z isn't constant either. It changes sign over cosmic history, aligning with the different phases of expansion.
So let's get this straight then. How does EGM fundamentally redefine what dark matter and dark energy are?
EGM's bottom line is no requirement for dark matter, dark energy as distinct, unknown substances needing exotic new particles.
Okay, so what are they?
Instead, in EGM, dark energy is identified simply as the energy of photons, their massive photons, contributing a fixed 50% of the total energy mass budget. Dark matter is identified as the energy of gravitons, their massive gravitons, making up a variable amount currently calculated at over 26.3%.
Wait, only 26% for dark matter. SMONC needs much more than that.
Yeah, but here's the crucial claim. EGM asserts that a significant proportion of dark matter has been misidentified by SMOC as being dark energy. The EGM says that 17.73% isn't curvature energy, it's actually graviton energy, dark matter, that SMOC make labeled as dark energy.
So if you add that back.
If you add that 17.73% to the directly calculated 26.3%, which they say is also dark matter gravitons, you get EGM's total dark matter contribution. Their proposed breakdown for the present epoch is dark energy, photons, at 50%, dark matter gravitons at 44.02%, that's 26.3 plus 17.73 roughly, and baryonic matter, the normal stuff we see, at 5.98%.
So 50% photons, 44% gravitons, 6% baryons. That adds up to 100%. And no need for WIMPs or axions or anything exotic.
That's EGM's claim. It simplifies the cosmic inventory dramatically by explaining the dark components using particles already inherent to their framework, photons and gravitons, just giving them mass.
It really does seem like the core theme running through all of EGM's explanations is that things we thought were fixed are actually changing over cosmic time.
Absolutely. That's a fundamental challenge EGM throws down to the standard model. They explicitly state that the majority of significant cosmological metrics, if not all, vary with time. This includes lambda, the omega density parameters, the deceleration parameter Q, the Hubble parameter H. This dynamic, time-varying nature is absolutely central to how EGM explains cosmic evolution and claims to resolve those SOMC puzzles.
This dynamic picture then leads naturally into EGM's own story of the universe's entire history, its evolution, and maybe even its ultimate fate. What's that grand narrative, according to EGM?
Yeah, EGM describes this whole cosmic process as a dynamic cycle. It's based on the interplay between what they call kinematic mass energy, it's the energy locked up in the cosmos, photons, gravitons, baryonic matter, and potential mass energy, EZPF, which is the energy residing in the zero-point field.
Okay, so energy shifts between the cosmos and the ZPF. How does the cycle actually play out?
Well, conceptually, it starts at time zero, where presumably all energy is in the ZPF, so 100% ZPF, 0% cosmos. Then there's a creation phase between 0 and their Big Bang time tie, where ZPF energy gets converted into the kinematic energy of the cosmos, photons, gravitons, eventually matter form.
So the Big Bang isn't the absolute beginning.
In EGM, the Big Bang event, tie, is more like the completion of this primary energy conversion phase. At tie, you have maximum cosmos energy, 100% cosmos, 0% ZPF. Then, after the Big Bang tie, the whole process reverses.
The energy goes back from the cosmos back into the ZPF. How?
Yeah, it returns through various physical processes described in quantum field theory and their model. Photons go back via annihilation. Gravitons decay into those entangled photon pairs, which then also return to the ZPF. Even baryonic mass participates by curving spacetime. It radiates gravitons, and those gravitons eventually decay, returning their energy to the ZPF.
So over truly immense timescales, everything dissolves back into the vacuum energy.
That's the idea.
Yeah.
In the very distant future, all the kinematic energy of the cosmos returns to the ZPF. You end up back in a state of 0% cosmos, 100% ZPF.
And then does it start all over again?
That is EGM's conjecture, yes. It implies a truly cyclic universe. They have this oscillatory cosmological model, or OCM, which even gives specific timelines for these different phases, like when baryonic matter evaporates, when gravitons decay, when photons fully return to the ZPF, and when the cycle might reset. They use a theoretical time unit called TL for this.
Cosmic reset button?
Kind of. They do note that their OCM idea has some philosophical parallels with Roger Penrose's conformal cyclic cosmology, C3, although the underlying physics might be different.
This whole picture of a dynamic, expanding, maybe cycling universe, does it have implications for the speed of light too? Does EGM suggest C isn't constant?
Ah, yes, the variable speed of light, VSL question. This is a point that the sources say needs careful handling within EGM. Their framework does imply a VSL, but only over cosmological time. And this variation is tied to the history of that space-time refractive index, KPV. But the key is who is doing the observing.
Okay, that sounds crucial. Who would actually see the speed of light changing?
According to EGM, only a hypothetical distant observer residing at infinity would measure VSL. Someone completely outside the gravity well of our universe. Imagine an observer in an alternate universe watching ours expand. That observer would see the speed of light in our universe change over time.
But what about us, observers inside our universe?
For any observer within our universe like us, the speed of light c will always be measured as constant in any local inertial reference frame, just like Einstein said.
Why the difference?
Because in the EGM model, our fundamental tools for measurement, our ruler plus clock, how we define meters and seconds, are themselves tied to and scale perfectly with that cosmological refractive index KPV and the overall expansion of spacetime.
So C appears constant to us because our measuring tools are stretching or shrinking right along with the changing spacetime properties.
Exactly. It's a subtle but crucial distinction. EGM suggests that while we always measure C as constant locally, hints of its cosmological variation might perhaps be detectable in very subtle, anomalous fluctuations in the cosmic microwave background. They even predict a time frame that the speed of light, as seen by that hypothetical distant observer, started decreasing in our current epoch sometime between 3.4 and 4.6 billion years ago.
Wow. Okay, if C varies for a distant observer, does that mean other fundamental constants change too? Like the fine structure constant, alpha. That's usually thought to be absolutely constant.
That's another important point of clarification in the sources. Despite the dynamic vacuum and the potential VSL for distant observers, EGM predicts the fine structure constant alpha does not change over cosmological time. It remains invariant.
Why not? If C changes for some observers and alpha depends on C.
Because alpha depends on the elementary charge, Q, Planck's constant h, and the speed of light related to 0 and A. In EGM, QH and the zero ratio, which defines C in the vacuum, all transform or scale in exactly the same way as the properties of the polarizable vacuum change over time. So their ratios, which define alpha, remain perfectly constant.
Okay, that's a neat way to preserve that invariance. True. Okay, we've covered a lot of ground. Pulling all this together, what's the elevator pitch for this EGM construct?
Well, it's presented as this really compelling, highly integrated theoretical framework, isn't it? It tries to derive literally everything from one single starting point, that quantization of gravity. And in doing so, it directly challenges some really core ideas in the standard model.
Like massive photons.
Massive photons, massive gravitons, and crucially, the idea that key cosmological parameters aren't constant but actually evolve with the universe.
And its big claim is that this new perspective offers solutions to some of the major roadblocks in physics and cosmology right now.
Exactly. It claims to resolve things like the Hubble tension, the flatness problem, that huge force ratio puzzle. And it reframes dark energy and dark matter completely. Not as weird, unknown stuff, but as the inherent mass energy of photons and gravitons within their structured vacuum, all leading to this picture of a dynamic, evolving, maybe even cyclic universe.
What do the sources really emphasize as EGM's biggest strength, the points they want you to take away?
They really hammer home its claimed predictive accuracy, that Hubble concept prediction from 2008 being the prime example. They stress that it's supposedly derived from first principles with, and I quote loosely here, no reverse engineering or ad hoc fixes, just to match data. And they constantly point to its high degree of internal mathematical consistency across different areas as evidence that the framework is solid.
So, for you, the listener, hearing about all this, what does it mean to engage with a framework like EGM? It sounds complex, maybe even improbable in parts.
Yeah, and that's okay. I think it's a really powerful reminder that our understanding of the universe is absolutely still a work in progress, right? Engaging with theories like EGM, even if they seem out there or challenge deeply held beliefs, is valuable. It pushes the boundaries of how we think.
Gets you question assumptions.
Exactly. It forces us to question those assumptions we might take for granted and to consider how seemingly separate bits of physics, like, the mass of one tiny particle and the expansion history of the entire cosmos, might actually be profoundly and fundamentally connected. It just shows that the quest for that unified picture of everything is still very much alive and full of potential surprises.
That really does make you think. Maybe let's leave you, the listener, with this thought to ponder. If photons, these particles of light we've always pictured as pure, massless energy, actually do carry some tiny amount of mass, no matter how incredibly small, what does that fundamentally change? How does that shift our understanding of light itself, of energy, maybe even the very nature of space-time? Could that infinitesimal mass be a hidden key, something we've overlooked that might unlock some of the universe's deepest secrets?